This cantaloupe is delicious, and it's going to help us learn some science in this episode all about potential and kinetic energy. When we drop this cantaloupe, potential energy is converted to kinetic energy. But what is energy? Energy is the ability to do work, which is the ability to exert force, causing displacement of an object. Or simply, energy is the force that causes things to move. All energy can be classified as either potential energy or kinetic energy. Potential energy is stored energy, and kinetic energy is energy of motion. Let's take a look at some examples of each type of energy. Kinetic energy can be mechanical kinetic energy or moving objects, like riding a skateboard or a cantaloupe falling to the ground. Thermal energy, vibrating and colliding molecules that affect temperature, like toasting a marshmallow over a fire. Electromagnetic energy, or radiant energy, that are light waves, both visible and invisible, like sunlight, microwaves, and X-rays. Sound energy, particles bumping into each other to transmit sound that travel in waves, like a trumpeting elephant. Electric energy, the flow of electrons through a closed circuit. This energy powers electronic devices, like whatever you're using right now to watch this episode. Then there are the potential energies. Gravitational potential energy, stored in the height of an object, like resting at the top of a slide. Elastic energy, stored in the compression or stretching of elastic materials, like the stretching of this balloon. Chemical energy, the energy stored in chemical bonds. This could be fossil fuels or energy stored in a battery, sunlight absorbed by plants, or even energy stored in the calories inside the food we eat. Or nuclear energy, that is stored in the nucleus of an atom. The amount of kinetic energy that an object has depends on both its mass and its velocity. More mass and/or more velocity means more energy. The amount of potential energy depends on both the mass and the height of the object. More mass and/or more height means more energy. If you're still here liking this video, let us know and hit that subscribe button so you never miss an episode. So in other words, you would rather have a ping pong ball dropped on your head than a tennis ball because a ping pong ball has less mass. You would also rather the tennis ball drop from 2 feet above your head than the top of a building because the tennis ball would develop less velocity. The amount of potential energy of an object can change based on how it's arranged. For example, a cantaloupe resting on the top edge of a building will have more potential energy than a cantaloupe resting on top of my hand, since the cantaloupe way up there has more potential distance to fall. All forms of energy can neither be created nor destroyed. Energy is only transferred between an object or a system. For instance, when you roll a cantaloupe up a hill, it has kinetic energy because it's moving. As it slows and stops, the energy of motion is transferred to the potential energy in the cantaloupe's position. The potential energy of the cantaloupe can quickly be converted back to kinetic energy when it rolls back down the hill. The energy of the cantaloupe gets transferred between potential and kinetic forms, so energy is conserved. Did I find a sale on cantaloupes? Yes, I did. This is a K'NEX coaster. It's very similar to a regular roller coaster, except this one doesn't make me want to throw up. Let's see if we can determine the levels of kinetic and potential energy our cart has as it rolls through this coaster. When the cart is resting at the very top, it has the greatest potential energy. It is resting at the highest point. When the cart is released and begins to be pulled down by gravity, its stored energy is transformed into kinetic energy. As the cart goes down the first curve, its kinetic energy increases while its potential energy decreases. The same is true as it travels through a loop. High potential energy at the top of the curve. That energy transfers back to some potential energy at the top of the loop, and then quickly back to kinetic energy. As the cart goes up a hill, it slows down a bit because the gravitational potential energy is taking away its kinetic energy, and then quickly back to kinetic energy as it reaches the lowest point of the K'NEX coaster. Potential and kinetic energy are literally all around us. See how many types you can identify today. And if you want to learn more science, you can check out this video next.